Okay, guys, thanks for joining. Today we will be discussing about the rows on Docker topic. By the way, Happy New Year, everyone. So this year we will be this month mostly, we are planning to conclude the rows one topics. So, we have few chapters remaining, the Docker and CI, then the drones. So there are I think four chapters. Okay, I hope we can complete that within January, and then we will be starting with ROS 2. Okay, so today we are discussing an important, very useful topic for you. I can introduce that. Without much difficulties, and I can show you some demos, and I can also share some codes so you can practice it. Okay, so in our syllabus, I think if you check the first topic in the sense, we already discussed about Docker. What is Docker? I think, yeah, this one. So I have given some idea about Docker and what is the use of it. Anyway, I will repeat some of the portion again, and then I will be showing what is the actual purpose of Docker. Okay, while working with ROS. So let me just take the syllabus, and this topic is coming in ROS 2 as well. So if you know how Docker works with ROS 1, it's the same with ROS 2. There is not much difference. Okay, so I can say a scenario. We can start from that. Okay, let me take a browser. Docker diagram or something. Let me see. Okay, I'm not sure how many of you heard about Docker. We already discussed about Docker in our first lectures, but I'm not sure you have attended or you have seen that lecture. But I can give you a good idea about Docker first. So guys, if you're working with any technologies, okay, even if it is ROS or C++ or anything, how will you, start creating application? You have a Linux or Windows based machine, and you will be writing your program, and you are compiling it, and you are building it, and you are shipping your software, right? So if you're creating a package, okay, if you're creating some ROS application, how you are going to ship that package? You can actually put it in GitHub, right? You can put that packages in GitHub. So for example, if you just check the navigation to, it's actually a package in ROS 2. Okay, let me take that ROS 2. Okay, I'm taking an example. Okay, so this is a ROS package. Okay, and this is how we are distributing this software, right? And so in order to work with this package, what do you have to do? You have to build it, or you have to install it somehow, right? So when you take this build and install section of navigation 2, you can see here, you can install it from binaries. You can use Docker, and you can use Docker container, and you can see a word called Docker here. Okay, so what is Docker? So that is what I'm planning to discuss first. So Docker versus virtual machine, Rob Academy. I think I am already documented that. Yeah. Right. I'm just sharing that link. Okay. Okay. So you already know how the virtual machines work, right? So I just want to take I just want to take this one. Yeah. So you may know like how a virtual machine work. So I'm working with the virtual machine in which like the host operating system is Windows 10 and the guest operating system which is running on virtual machine is Ubuntu 20.04. Okay, and the virtual machines are kind of software. Okay, kind of software that is currently running on Windows. Okay, so that is what is showing here, host operating system. Okay, here in my case it is Windows, and the virtual machines is having a piece of software called hypervisor. Okay, this hypervisor is actually a program that can allocate system resources for guest operating system. So here the Ubuntu 20.04 is the guest operating system. So the hypervisor can allocate some resources for that. So you can see on the top of hypervisor, based on your system configuration, like you may have 4 CPU, 8 CPU, 16 GB of RAM or 32 GB of RAM, you can divide it. Okay, so you can allocate 16 GB of RAM to a guest operating system. Okay, and you can run a guest operating system. Okay, but imagine like if you are running your host operating system currently is Windows, and if you are running multiple guest operating system on the same machine, make sure these resources that is allocated for each guest operating system satisfying the requirement. Because here in my case, if I'm taking the task manager, I can see the memory is like the usage is like 15.9 GB out of 16 GB RAM. I mean 14.2. Okay, 14.2 GB RAM out of 16 GB of RAM. So it's mostly using, the RAM is actually using. Okay, so if I'm running another virtual machine, same virtual machine, okay, like the ROS book, if I'm running, then my host operating system can't able to run it because it actually require more RAM, right, and also more CPU. Okay, so the virtual machines are like allocating the resources for the guest operating system, and mostly the complete desktop or complete operating system is running on the virtual machine. So what are the advantages and disadvantages? Advantages is like it's very easy to work with. Like if you take the VMware or VirtualBox, all these are like virtual machines software. So if you take it, you can simply install the virtual machine on your system by simply clicking this create new virtual machine. Okay, and you can just browse the image file, Ubuntu image, that we can download from the official website, and you can install virtual machines on it. So it's very easy, and it's very similar to the workflow like that we are working on a real Ubuntu system. Okay, but the disadvantage is that you need to install full operating system, so it will obviously take more space, like 10 GB, 15 GB or 20 GB of RAM, 20 GB of hard disk, and also it's sharing the resources. So I mean the guest operating system is taking resources from the host operating system, so like the sharing is happening. Okay, so the host operating system may not get the complete resources for its operation. Okay, so on the left side you can see Docker, which is a different approach. Okay, which is actually a different approach. Here there is a host operating system, and on the top of the host operating system, in case of Docker, there is a Docker layer. Okay, so how that is working is that the Docker is actually a kind of it's not equal to the hypervisor in the virtual machine, but it's work like we are not running the full operating system. Instead of that, we are running an instance of the operating system. So the main purpose of Docker is like running an application instead of running a complete operating system. So here we are seeing we are running full desktop version of Ubuntu, and we can maybe run an application on this virtual machine as well. Okay, so more than virtual the application, more than the operating system and application, Docker is mainly focusing on deploying application. For example, if you create a color detection application, okay, you created a ROS package, and you have to deploy it, or you have to distribute that software. So you can create a Docker contain or Docker image, and whenever we download, okay, or pull that Docker image and run that Docker image, then you will get that application working. Okay, so it is actually running an operating system. Okay, only the required things for working with the application. For example, if you running this color detection program, it is having the things that is required for running that color detection. So if it need ROS, the Docker image will have ROS installed, then OpenCV installed. There is nothing other than that. Okay, only the dependencies that is required to run that application. So that is very important. But in case of virtual machine, it is having all the stuff. Like if you check, it is having the music box, browser. But if I'm running the color detection program on virtual machine, do we need this web browser for the color detection application? No, right? Is it requiring a desktop environment? Maybe. Okay, is it requiring the game in Linux? No, right? So Docker is focusing on removing the unwanted things in the operating system and running a lightweight instance of the kernel and also the operating system. So what are the advantages? The advantages are space is less, and also the resource is also like the Docker is working in the Linux kernel. It's actually working along with Linux kernel. So it's like it's not running separately, it's working along with the host operating system. Okay, so the advantages that we are getting if you are learning Docker is that, suppose you create some kind of application on your machine. Okay, and if you want to reproduce that result, or if you want to run that same application in another computer, the best way is that you can create a Docker file. Okay, Docker file, and if you run that Docker file, it will be creating a Docker image, and you can distribute that Docker image to anyone. Okay, so anyone can pull that Docker image and run that Docker image, so you can reproduce the result. Okay, so you don't need to install all the dependencies required for the application. You only need to focus about uploading or downloading that image. Okay, so the Docker image is like a wrap. Okay, wrap of all the dependencies required to work with the application. So in these two images, you can see there is app A, B, C, D, and here is also app A, B, C. But the main difference is, like on the virtual machine, there is a guest operating system, complete guest operating system is running. But in case of Docker, it's mainly running the application, not running the full guest operating system, but an instance of the operating system. Okay, so just understand that Docker is one of the best way to deploy your application. Okay, deploy and test your application within a very less span of time. Otherwise, you have to install all the dependency, you have to install all the operating system and test. Okay, so there is a question, what about now? It's a voice stable now, Bharat. Also you can check, is it because of your side, if there is any problem with your network. So if you have any problem with the sound, please let me know so I can check it my side. Here in my side it looks good. You can see here it's green here. Okay, so that is the main difference between Docker and virtual machine. And if you just search for Docker, you will get the official website of Docker. Okay, so you can see here the Docker for Windows, Linux, and there are a lot of tutorials as well, and a lot of companies are using Docker in order to deploy the applications and in order to test and benchmark. Okay, so the next thing is that, so I'm initially discussing the basic stuff. So in order to set up Docker, there are installation instructions. Basically, if you just search for or I think it will be here on the getting started. Let me check Docker download for Linux. So if you just check this, you can able to see the installation instruction for Docker in Linux. So it is compatible with Ubuntu, and so if I'm clicking here, you can find some Debian package that you can install, or some commands also there, so you can easily set up Docker based on these instructions. Okay, and also there are multiple tutorial Docker install Ubuntu 20.04. I think, let me check. There are multiple tutorials that you will get from the official site, and also here you can find multiple tutorials. Okay, so I will say Docker is something that we can install on Linux and Windows, and it is actually the part of operating system on the host operating system. And using the Docker technology, you can wrap your application inside a container. Okay, if you just check the Docker logo, I'm just showing the logo. You can see here, you can see the container. You know what is a container is, right? Container ships. So a container, physical containers are like, it is having something. Maybe it is having some products, it is having some raw materials. It's all contained inside these physical containers, right? The same concept applicable for the Docker technology, Docker application. So inside the container, we are wrapping all the dependencies for an application. Okay, and there are some terminologies that you have to understand while working with Docker. I think I have mentioned in the first tutorial, but if you are not aware, I can again mention. So one is the Docker container, okay, and one is Docker image. So maybe if you just search for Docker terminology, I think maybe I can start with the Docker image. Yeah. So maybe I can explain. You can also search a Docker image is actually the file that we are getting after installing all the dependencies and the application. Okay, so the applications and the dependencies are stored inside the Docker image. It's a physical file. You can transfer that file. Okay, it's kind of an image, or if you just check the virtual machines, just a second, I can show you a thing like VM. Yeah, so this is some files for the virtual machine or from using VMware. So you can see some physical files, and there is some file which is having 30 GB. Okay, so there are some file. So similar to that, Docker image is a physical file which is storing the application, the dependencies, and the OS footprint. Okay, so it is holding some size. Okay, so if you install Docker, and currently in my virtual machine I install Docker using the tutorial instruction, and after installing I will get a command line called Docker. Okay, so I will get a command called Docker. So if I'm just typing Docker, it is having some subcommands, Docker space image. Okay, so we can just check what is that, Docker space image or images. So you can find there are set of images present in my image list. Okay, so you can find recently I created this image, and there is Ubuntu image, and which is having size of like 3.72 GB, 3.44 GB. Then Ubuntu is having 72 MB. Okay, so these are the images, that is the physical files present in Docker. Okay, physical files. So it is having all the application and dependencies. Okay, so whenever we start these images, start the images means it's like booting the operating system. So if you take a virtual machine, you can boot or you can start the virtual machine by pressing start button, right, or power on. So similar to that, if you just start this image, then so in case of virtual machine, if you start the virtual machine, you will get the operating system, right? You will get all this. So we can say it's an instance, right? When you start this virtual machine, we are getting an instance of that operating system, right? And instant is this is the instance. Similar to that, if you start the Docker image, okay, Docker image, you will get an instance. Okay, I mean running instance. Okay, if you run the or if you start the Docker image, you will get a running instance of the Docker image. It's called container. Okay, so when you run or when you start a Docker image, you will get a container. Okay, that is called an instance. Okay, and we can use various commands to run an instance, run a container. So here for demonstration, I think we can use an Ubuntu image. Okay, Ubuntu image. I'm showing some sample commands, and I will also share the Docker command reference. If you just search for command reference, you will get tons of commands. I will share some useful commands that I felt. Just a second. These are like official command tutorial or something. That will be good. Yeah, I think on tutorial points maybe. Yeah, this will be good. This is the simplest way to try out the Docker commands. Just a second, guys. Yeah, it is having something. So I can share the basic commands to interact with Docker. So what I'm trying to say is that I'm planning to start an image. Okay, that is what I'm going to show you. So Docker is the command, that we got after installing the Docker application on Ubuntu. And then in order to run the image, I'm just using docker space -it, then run Ubuntu bash. Let me check. I think run it. Yeah, I think that actually worked. So guys, you can see here this command. What I'm doing is I'm running the Ubuntu image on Docker. So in order to run the Ubuntu image or any image, you can use a command called run. Okay, in order to get the tutorial of various commands in Docker, just type Docker and you can find various commands here. Okay, for example, if you see here run, so what is the use of the run command? Run a command in a new container. Run a command in a new container means like we are just starting a container and then we can start working with that container. Container is the running instance. When you start the image, you will get a container. Okay, so that's what I'm trying to show you. Run space it means interactive. Okay, so what happening is that it's running Ubuntu. It's starting the Ubuntu image, and it's executing a command called bash. Okay, so bash means the terminal. Okay, so it's starting Ubuntu and starting the terminal. So that is what we are seeing here. Okay, so this terminal is not this terminal. This is the terminal from the Docker container. So if you just enter ls, this is different actually. Okay, this terminal is different. I hope you got an idea. Like this is a different thing. Okay, it doesn't have anything. Like if you press nano command not found, it's not installed. Okay, and you can update. Okay, so we are working from Ubuntu 20.04 and we actually started another Ubuntu instance from the terminal. That's what we have seen now using Docker. Okay, so we can able to work with another Ubuntu instance from another Ubuntu. Okay, it's like virtual machine. Like here I am working from Windows and I am creating a virtual machines that is running Linux. But here what I am doing is I am inside this virtual machine. I'm installed Docker and ran Ubuntu. Okay, so Ubuntu started and I got the terminal. Okay, so this is the terminal, and then you can do anything you want. Okay, so this is how we can start a terminal. We can start an image and create a container and interact in the terminal. Okay, so there is a thing like this is one terminal. What about creating another terminal? Okay, I just want to create multiple terminals for the same container. Okay, so if you want to work with this container, you can check a command called docker ps. Okay, docker ps is actually showing us what are the containers or what are the instance that is running now. So currently there is only one instance of Ubuntu is running. Okay, and there is a thing called container ID. Okay, container ID, and the image is Ubuntu and some timestamps. Okay, so if you want to create another terminal of the same container, what you have to do is you can simply copy this container ID, then use docker exec. Okay, don't use docker run. In order to run different terminals or in order to access different bash in the same container, use docker exec. Okay, docker exec, then -it, then the container ID, then bash. Okay, so you can able to see here this name and this name is the same. Okay, that ensures that we are working inside the same container. Okay, I can prove that. I'm just switching to the okay, so here you can find the system files, right? Let me create a file called lintin. Okay, just a second. Let me write I think cat. Let me just try to test. Echo, sorry, echo. So what I'm trying to do is I'm trying to echo a text called lintin. Okay, and that text will be writing to a file called test.txt. That is what this arrow indicates. Let's try this. Yeah, actually it's worked. And when I'm do the ls, you can see here we have test.txt. Okay, just type ls here as well. You can find test.txt. Okay, and if you do cat test.txt, I'm getting lintin. Okay, so what we have done here, we have started an Ubuntu image and we created a container. Okay, container simply means like it is an running instance of your operating system or your application. Okay, whatever it is, like it can be an Ubuntu instance or like ROS instance, anything it can be. Okay, and we got the container ID from the Docker PS. So if you have doubt about Docker PS, just type Docker and just scroll down and you can find PS stands for listing the containers. Okay, listing the containers. Okay, and after getting the container ID, you can use the Docker exec. Okay, Docker exec -it to enter into the same container. Okay, if you want a different container, then if you can use the Docker run. Okay, some cases we need to run application in different containers. In some cases we need to run on the same container. Okay, so this is some basic knowledge that you need to have. Okay, to run the Docker images. If you have a Docker image and you can execute it. Okay, you can run it and you can have access to the terminal. Okay, so now I can show you an example of what we really seeking in this session. Okay, so we are trying to practice some of the tutorials that is mentioned in the ROS wiki. So we can see here there are several tutorials, like in order to work with ROS and Docker. There are several tutorials that is mentioned. So that is what we are practicing now. Okay, so what do you mean by ROS and Docker? I mean, why we have to use ROS and Docker? By the way, if you want to exit from the container, you can simply press Ctrl D, so it will be exiting. Okay, Ctrl D, that will be fine. So by the way, like, what is the purpose of using Docker while working with ROS? I already mentioned that you can create a very big application or whatever, a small application or something, and after creating, if I want to run the same application in my computer, either I can install the necessary dependencies and try, but the problem is that imagine you're working with ROS Noitic. Okay, and I am working with ROS2 Humble. Okay, and from my PC I need to run your ROS Noitic application. How can I do that? Because ROS2 Humble is mainly working on Ubuntu 22.04 and ROS Noitic is mainly working from Ubuntu 20.04. Okay, so there are difference in the ROS distribution, Ubuntu versions, but if you want to run any of the ROS application on any of the Ubuntu distribution, for example, if I'm working with 20.04 here, okay, this is 20.04 Ubuntu 20.04, and if I want to work with ROS2 in 22.04, I can simply do that using Docker. Okay, I can do that using virtual machine. Like I can install VMware or something and install 22.04, and then I can work with 22.04 and 20.04. But you can do the same thing using Docker with much faster, with less space, and more I will say more effective or optimized way of doing. Okay, so that is the main purpose why we are using Docker in ROS, because you can run any distribution on any Ubuntu version. So you don't need to like reinstall your operating system to run the application. Rather than you can simply install Docker, and then you can run any application. Okay, so what I'm trying to show you is an example that is running Gazebo. Okay, not from the Ubuntu that I have installed, but from the Docker. Okay, from the Docker. So let me show you that. After that you will get an idea. Okay, so that example is what I am trying to explain to you. Okay, so this example actually there was a competition called Art Park from IIC Bangalore. So I actually mentored one team, and this was one code, or this was one Docker file that we have created to run that code. Okay, so I can explain that after creating the, or after showing the demo. So here I am running the Docker. Okay, so the command is bit lengthier. The Docker run with some other thing. Maybe I can show you the command that we are running. So this is the command that we are going to run. So basically it's a Docker run IT, but in order to run the GUI in if you want to run GUI application in Docker, we need to add some more things. Okay, and this is a command that is going to execute, that is gazebo rows empty world. Okay, so let's see what is gazebo rows empty world. If you just check on our machine, what is the output that we are getting? Let's see. So if you run empty world, the output that we are getting is, it will simply come up with gazebo, and there is nothing in it. That is empty world. You can add obstacles into it, cylinders, everything. Okay, so what I'm trying to show you is that I'm running the same thing from Docker. Okay, I'm going to run. So I'm running run sim.bash. That is the command. Inside that file, the Docker run command is there. So simply run sim. Just a second. It's showing some conflict. Just a second. I need to remove something. Docker. Yeah, let me just clean up some. Okay, so I'm running run sim bash. You can see here it's running the same thing. We have gazebo, okay, and the gazebo is not, it's not from the real operating system. If you just check the, yeah, actually, oh, that's interesting. Yeah, it's actually sharing with the PC, but okay, this is interesting. I didn't check the topics. Actually, we are getting in the real PC as well, but it's basically running from Docker. Okay, it's basically running from Docker, and I can show you the Docker PS output, and you can see here, this is what, this container is what we running. Okay, you can see the simulation, right? So instead of this simulation, it can be anything. It can be navigation or any kind of application. When you start this Docker run, it will be like popping up with some simulation or some image processing application. In case of the challenge, so whenever we start the Docker image, okay, whenever we run it, it will be coming up with the simulation and all the challenge code that we have developed, and the robot will start working autonomously. So that is a challenge. So I think I can show you that the challenge was Art Park robotics challenge, and they have some set of requirement. Yeah, 2021. Yeah. So yeah, here you can see yeah, these are the winners. The team that I have mentored, they reached the final, but they couldn't complete the, there are some issues with the code. So this was a challenge, and here are the robots that they developed. So these are the guys that I have. Jerin was there, Jerin, and yeah, three of, and this was the robot they have developed. Actually, the robot was quite good. If you look the appearance of the robot, this robot was actually very good. It looks good, but the software was not. It was not working as expected. Yeah. So yeah, this was a challenge actually. So whenever we start the the Docker, the robots start working. So that was a challenge actually. So here you can see it is running an instance, right? So now we are accessing a terminal from this container. Okay, we got the instance, and then we are just sourcing an entry point thing. I will explain what it is, and then you can see the topics. Okay, that the topics that we are getting from the gazebo. Okay, so basically we are running a ROS simulation or ROS application from the Docker. Okay, it's not the terminal based application, it's a GUI application. Okay, so that is the importance here. Okay, so this will be very useful, guys, because if you want to create your own simulation, and if you want to deploy it, these set of files will be useful. Okay, so I am actually going to explain how we can do this. Okay, how we can use ROS with GUI from Docker. Okay, so here if you run it, just a second, this issue is coming most of the time, but I'm not sure. Just a second, I'm running it again, and I can show you, like, I can run the gazebo. I'm running it again just for showing the GUI capabilities. I'm taking the container ID, okay, then creating the bash, okay, and you can find ROS entry point, right, which is basically like a bash-RC thing. It is having set of variables, okay, like here it is sourcing the ROS bash, okay, so then we will get all the ROS commands, okay. So I'm simply sourcing the ROS entry point, and then what I'm doing is I'm starting RQT, okay. So here you can see I'm getting RQT not from the real operating system but from Docker, okay. And I can start the topic monitor, and then I can just echo the topics, okay. And in the next terminal I'm starting another terminal for the same container, and then sourcing the ROS entry point, which is having the source command for ROS that we are commonly put in bash-RC, and then I'm starting RVs. So the RVs is coming, okay. So these things are not from, it's not from the Ubuntu, the Ubuntu that we are working from. It is all from the Docker. Interesting, right? Like you can work with ROS without installing on real PC. You can simply install Docker and then pull or like download some ROS Noetic images, and you can start working with ROS. Okay, right? Okay, so that is what I'm planning to show this session. Okay, I'm just closing everything. Okay, closing it. Okay, so this was our code, and you can see this code from the official ROS tutorial as well. Okay, you can find it from a lot of tutorials are there. Okay, so let me start with the first one, that is runsim. No, not runsim. Start.sh. Okay, start.sh. Okay, so so now I just want to explain about a topic, a concept in Docker. I already, I think, mentioned the first class, but I will talk about it. So there is a concept in Docker called Dockerfile. Okay, Dockerfile. It's very simple. Inside the Dockerfile, we can actually mention which operating system we want, or which Docker image, base image that we want. Okay, so I can explain what is a base images. For example, if you want to create a ROS Noetic application, okay, if you want to create a ROS Noetic application, ROS Noetic application, in order to install ROS Noetic, you need Ubuntu, right? And you need to install ROS Noetic desktop full, then you may need to install OpenCV, all this stuff, right? What about just using a ROS Noetic Docker image, okay, on your application? Okay, imagine there is a ready-made Docker image for ROS Noetic desktop full. Okay, if there is a Docker image for ROS Noetic desktop full, do we need to install ROS from scratch? No, right? You don't need to install Noetic on Ubuntu image. Okay, so there is a concept. First, there is a concept called base image. Base images are like the foundation images. Okay, I talked about Docker images, right? So the base Docker images are like, there is a base image for Ubuntu. Means you can simply download that base image and you will get the standard Ubuntu. Okay, standard Ubuntu. So for understanding that, if you just go to Docker Hub, this is a website that we can host these base images. Okay, so you can simply download these images, okay, and then you can put your application on these base images and then create a new image which is having the base image and your application. So here, like if you want Ubuntu, you can simply use this command called docker pull Ubuntu. Okay, so docker pull Ubuntu, what it does is that it will be downloading this base image, Ubuntu base image, from the Docker Hub. Okay, so you can select which Ubuntu we need. That is also there. Like you can put the tags. If you simply put docker pull Ubuntu, then it will be pulling the latest version. But you can mention which Docker image that we require. Okay, and also like if you want ROS Noitic, okay, if you simply search or simply search for ROS, I think. Yeah, so there is official image for ROS. Okay, that means if you want to work with Noitic, okay, you can simply pull this command. Okay, Robot Buster, Perception Buster, Galactic, I mean any version. Okay, so that means you can download any ROS version from the Docker Hub. So the question is, Kalpesh is asking, is it possible to Dockerize Ubuntu from Windows? Yeah, so I think from my understanding, Docker mainly work from Linux. Okay, there is a Windows desktop thing, but I think we can only run it. I need to double check that because I mainly work with Docker on Linux. Okay, so but we can have, I mean, interact with Docker using a GUI from Windows, but I'm not sure that we can able to build Docker images from Windows. I need to double check. I think there is a application for Windows, but I don't know like whether it is limited or something. Like maybe we can only do something that I need to check. I think it is very limited. There are something that we can do, but not like Linux, I guess. I will check it, Kalpesh. I have a confusion because I mostly work with Linux and not very much aware about like whether we can do the same stuff in Windows. Okay, because Docker is mainly tied up to Linux kernel. Okay, I'm not sure is there any alternative for the Windows kernel. Okay, so what I'm trying to say is that if you want any ROS versions, you can simply pull it from the Docker Hub. Okay, and then you can use that image and then you can install all your dependencies. Okay, so that is what we are seeing here. There is a file called Docker file. Okay, Docker file, this is the naming convention, Docker file. Okay, we can't rename it. It's like the CMake list or it's like the make file or something in Linux. So Docker file, if you open it, you can find tons of stuff in Docker file. Okay, maybe I can show you a simple Docker file as well. Let me show you a simple Docker file. Yeah, so this is a kind of very simple Docker file. you can see here, and I can explain what is going on with the Docker file. Oh, not XML. Is it Docker? Yeah. So the Docker file is kind of step-by-step instruction to build a Docker image. Okay. The Docker file is the step-by-step instruction to build a Docker image. So I mentioned that Docker image is having all the dependencies, all the application files that you have, and you can just send or like push it into Docker Hub, then pull the same Docker image. You can do it. Okay. So this is the Docker, a typical Docker file looks like. Okay. A Docker file is having set of things like the Docker file need a base image. Base image means we are working on that base image. For example, if you are installing a virtual machine, firstly you are installing an Ubuntu operating system, right? So that is, we can consider as a base operating system. Okay, so similar to that, if you want a Docker image as a base image, you can use a command called from. Okay, so in this sample the base image is Ubuntu. In this sample the base image is ROS desktop full. Okay, so the base image you can check it from the things, the ROS desktop full, from the OSRF. If you just simply search for the OSRF, you can find the base images. Okay, so I'm using one of the base images from OSRF. So you can find here, let me check. You can see here melodic desktop full, noitic desktop full. Okay, so this is what I am actually using, this command. I hope you can able to see Docker. So this is the base image that we are using in this Docker file. Okay, so imagine this base image is not available on your PC. Okay, then it will be automatically pulling from the Docker Hub. Okay, after installing this base image, this is actually like for working with NVIDIA GPU. If you have NVIDIA GPU on your machine, these are some environment that we have to create. We can ignore it now. Okay, and on the base image we are installing all the dependencies to install your application. Okay, so like you can mention you need to set up some more dependencies, and you can also like create a workspace. You can clone your repository and then you can build it, and you can install more dependency if you want, and then you can copy some files like we talked about the sourcing files, right? The ROS entry point or sim entry point. So if you want to add that, you can add, and after building you can start a bash command. So CMD means after doing all these things, the CMD is like executing this command. Okay, so simply if you execute this Docker file, what will be the end product? The end product will be another Docker image which is having the base image of noitic desktop pool and all these dependencies and all these things with your application. Okay, so when you run these, you will get a command line, and then you can start your application or stop your application. Okay, so this is the important part of Docker projects. Okay, so what we are doing here is on the start.sh we are building the Docker file. Okay, we are using a command called docker build. Okay, so you can see here the docker build, the uses build an image from docker file. Okay, build an image from docker file. Okay, so that is what we are using in this script. Okay, start.sh. So it's basically like building the docker file and then saving the images RoboJodians. That is the team name. Okay, so this is giving the permission of the sim entry point and run sim. It's basically like just it's not related to Docker. And when you run the script, it is checking whether if there is any image called RoboJodians. If it is there, remove it. RM is for remove. This is for building the Docker file. Okay, so this is a long process. I already built it, and after building, we are running the run sim, which is actually this file that is running the Docker image that we created. Running means we are creating the container of the image that we are created. So Tejas is asking, like, can we write the launch command in entry point of the Docker file? Yes. So maybe you can check here. The best way is, I mean, yeah, like if you check it, the entry point is mainly for sourcing actually. Like if you want to source some variables, the entry point is mainly for that. But if you want to run a command when you run this Docker image, you can add it here. Okay, like cmd this. You can put some ROS launch or something like that. Okay, you can add. So the command will be executing whenever we start the Docker image. Okay, so what we are doing is we are creating the Docker image and then we are running that Docker image. So using docker run it, we are starting the image called RoboJodians and we are running a command called ROS launch gazebo ROS empty world. Okay, all these things are Docker parameters. These things are for working with GUI. Okay, if it is not a GUI application, you don't need this. You don't need these things. Okay, and there are many other options, like you can share your folders to Docker. Okay, like using the volume option, you can mount a drive to Docker, and there are multiple options. You can share your internet. All these things you can use in Docker. Okay, so what I'm trying to show you is that a basic example, like with a Docker file, the Docker file is building a ROS application in ROS Noitic, and then we are simply running that application. Okay, so instead of this git clone here, what I'm doing is I'm just commenting this line. So like if you want to build your application, just put your git repository here. So this script will be automatically clone and build your workspace, and then you can launch your application. Okay, so make sure you have installed all your dependency here, or you can use ROS dep command to install all your dependencies. Okay, so this is the basic concept. Okay, this technology is very big. Okay, and I have given the basic idea in the first class, but this is again an useful session for like deploying your application using Docker. Okay, we have something to discuss like NVIDIA Docker, that also we will see maybe tomorrow. I will be announcing the date. So we will be seeing the NVIDIA Docker and the deployment CI/CD thing. Okay, continuous integration. So that is again related to Docker technology. So we are actually commonly discussing these two topics uh, together. Okay, so the basic concept, I think you got an idea, like building the image, running it, and then I mean, when you run the image, you got the container, um, and then you can start working on it. Okay. So Tejas is having a question. Will you cover ROS deep learning before ROS 2? Just a second. The ROS deep learning stuff, I think. Just a second. Yeah, I can talk about it. I think I mentioned about I mean, this chapter I mentioned about the YOLO ROS interface slightly, but I can give some more idea. Okay, yeah, state machine is actually the state machine. That's what I mean, chapters remaining. The state machines is pending, and um, the yeah, I actually know, like the drone um, chapter is pending, and the Docker is what we are discussing, these two topics. And in this chapter, like there are some topics that is added by another company. Let me see, that is still relevant because that is added before 1 year. But the topics that I have added is this: robot web tools, ROS Java, AWS, all these things that we can discuss. Yeah, so the TensorFlow, I think I can give you an idea. Okay, the TensorFlow, it's not a big deal. Okay, and after that we will be starting with the ROS 2. Okay, ROS 2 is having, I mean, most of the same stuff, but again it is having a lot of things. And you already know ROS 2 is what we are I mean, we are trying in future. Like in my further courses also, I will be like giving more importance to ROS 2 because it's somewhat matured now, and I also started working on ROS 2 now, so I have better clarity. Okay. Okay, guys. So now it's a time for questions. Like let me know if you have more question about Docker and ROS application deployment. I will be sharing this template with you guys, so you can also try it out. Okay. And next class I will be like talking about the NVIDIA Docker and the CI/CD thing. Okay. Yeah, so time for question, guys. So this is very useful topic, very useful. Using the templates, I think you can simply work it out. Yeah, so let me know. You can either ask or you can type. I think yeah. Yeah, so Kalpesh, I can share the competition link. Art Park Robotics Challenge. Art Park is actually a spin-off from IIC Bangalore. They are working on robotics, and I think there are a lot of opportunity there, both internship and yeah. Projects. They're working on some futuristic stuff. Just a second. Okay, yeah, this one. I have shared the link, Kalpesh. Yeah, so okay, Bharat is having a question. Whenever I open Gazebo, it's getting crashed. I'm using Gazebo 11. So Bharat, there are multiple issues for the Gazebo crashing. So if you are working with the real system, one of the issue can be with the driver, but if you are working with VMware, I can give you a quick solution. In VMware, there is a common issue with crashing of Gazebo. Okay, in VirtualBox as well. So I can show you the fix. So just go to the bash RC and then copy paste this line. This is not the, I mean, final way or like the best way, but this is a fix that works. Okay, so just add this line to your bash RC like this. Just a second. Yeah. Okay. So I also mentioned this problem. Academy OpenGL issue.
Basically, I did add that one already. I searched in the blogs and add this in the bash RC, but still, whenever I open it's giving the lot of pop-ups like there is some issue and
Okay,
can I
okay.
report the
So
error?
is it showing any error like this VNW IOCTL command error or something like that in the command line?
Uh, no, it is not showing. Actually, it is like a pop-up message. It is giving a GUI like whenever you have the uh,
Yeah,
like
yeah, yeah.
Ubuntu errors, right? So it's
Okay,
those
okay.
type of
So like
pop-up
if you're
messages I'm
not
getting.
adding this line, then you might get this error. So if you add this line, then this error maybe, I mean, it may be solved. But the error that you might get is something different. And let me check the Gazebo version that I am using. Uh, yeah, it is 11. Yeah, yeah. So I
It is
think it
11
is
only.
working fine here. But if you can share the error or some screenshot, maybe I can help. If you are working with VirtualBox,
Okay.
one thing you need to aware is that there are some settings in the graphics part. So like if you just go to the settings,
Okay.
display, you can increase the video memory to 128, and
Yeah,
maybe
actually
you
I did
can
it.
disable this
That all
3D
the proof.
acceleration sometime. Yeah, this
Okay. Okay.
okay,
That is enabled
okay, you
actually
can
for me.
disable that as well. You can try, because in VirtualBox I had
Okay.
these issues. I mean, these are all are some trial and error. But for video memory, how much was the video memory in your settings?
I actually won't
Okay.
remember. I am using another laptop. I recently brought especially for this one. I RTX 3060 with
Okay, so if that is the
high
case, then you can
configuration.
directly install
And
Ubuntu on your machine, because then only you can make use of the
I,
graphics. And yeah, so if you are confident to install Ubuntu on your real system, that will be great. Otherwise, you can try it like from the VMware, and then after, I mean, getting a confidence, you can directly install on the machine. Okay, so like if you are direct, yeah, tell me about it.
um, yeah, next
Yeah, yeah,
class I
sure,
will
sure,
take the
sure. Yeah, yeah.
screenshot and share you.
Okay, okay.
Yeah.
Yes. Okay, so I think that's it, guys. So Happy New Year again. So this year we are like planning to conclude the ROS 1 and starting with ROS 2. Yeah, it's again a lengthier session. Like we are discussing a lot of stuff in ROS 2. I am also learning things in ROS 2. So we can learn together, and hopefully like February after 20th, because I need to take a vacation on February, maybe for 1 week or something. Maybe after that, mostly we will be starting with ROS 2. Yes, so thanks for attending, guys. See you on next class. I will be announcing the next class soon. Thanks everyone. Bye.